when we talk linear functions, what do we think of? Do we remember formulas or anything vaguely? Y equals mx plus b should be the first thing that comes up for us, okay? That was what we called slope-intercept form. So slope-intercept form is our y equals mx plus b. On a side note, if for any reason you can't read something that I've written, it's because I'm writing on an iPad, I'm writing fast, and also my handwriting's not always that nice. So give me a shout. Someone else probably doesn't recognize it either. Any other formulas that we're familiar with from linear functions? Point slope form. Anyone remember what that one is?
Y minus y1, y equals
That one is standard form. Y minus y1 is our point slope form. M x minus x1. Yep, good. We are going to stick with those two. There are a few things that you will have learned in Algebra 2, like standard form is a great example of it. For some reason, that is taught heavily in Algebra 2. It is a good standardized test thing. It is, however, not super useful to us. So kind of at some point you learn it in Algebra 2, not for no reason, because you do need it for standardized testing and some other stuff, but there are things that we're going to kind of pare down a little bit here because we can. So we're really going to care about slope-intercept form and point slope form. There's one more formula I am thinking of that you may need to do equations of lines. Slope formula. So if we do our slope formula, that is known typically as y2 minus y1 over x2 minus x1. Some of you in physics this year will also see a representation of that as delta y over delta x, change in y over change in x. That's typically more of a word problem-y thing, but it may come up. Now, given that, thinking about those three different formulas that we have and then taking a look at number 1. If you are given the slope and given the y-intercept, which one do we use? Slope-intercept form. Yes, there are gimme questions. Y equals your slope, x minus 1. Okay. Now, when we get into all the different types, it's knowing what to use and when. When we see something like number 2, a horizontal line. Anyone remember any characteristics of horizontal lines? It's y equals, and its slope is always what? 0. Yes. I always remember horizontal goes with 0 because they both have z's in them, which might sound stupid, but it helps me remember, so it might help you. So just a side note on that one here, your horizontal line is always y equals a number, always has a slope of 0. Now, since it's y equals a number, what is the y value that we have there? -1. Good. So y equals -1, no work needed. Kind of slow remembering. Side note on that one as well. Horizontal line is y equals. What does that mean about vertical? X equals. So make yourself a note off to the side here. A vertical line is going to be x equals a number. Anyone remember what the slope is for that? Undefined. Okay, slope is undefined. Good. All right. Now that was kind of the easy ones. Now we're going to get into some of the review where we actually have to think. When we are given 2 points in question number 3, where do we start? Slope. All right, so I want you to take a minute on your own paper and find the slope between those 2 points. If you're fully confident going further, be my guest. However, if you're not, just hang out for a minute and we will chat about where to go from there. Once we have our slope, we have options. What's probably the best formula to use now? Point slope. Yeah. Some people, and I always have transfers in from other schools, you can use y equals mx plus b. It is possible. And if you are confident doing that, be my guest. I'm not going to show that because I've just found over the last 13 years of teaching this, point slope works better. Now, the nice thing about point slope is that the name says what you use. You use a point, any point, and the slope. Anyone have a preference as to which point we use? Sometimes there's a nicer answer than another. Some things to look at. I know I'm distributing a fraction of 1/6 into the x. If I do that, I might try for a nicer number that'll reduce with it, but I don't really have any nice ones there. You should get the same answer regardless of which point that you use. Did anyone last year when you do this, did they just leave it in point slope without solving for y? No? Okay. It depends on who teaches what year. I always have to ask. Algebra 2 is kind of a different teachers teach different things type thing. So I'm going to go ahead and use the first point. And we're going to do y minus, which is going to turn into a plus because of the minus and negative, equals my slope times x minus 5. We have had teachers that say leave it here. I prefer for you to solve it out for y. Just because that's the one that's going to help you graph if you need to. Y equals mx plus b just kind of feels like your answer always, and it should feel that way because we're comfortable with it. Note that this kind of thing is non-calculator. We don't have ours out right now. Yes, I expect to be able to distribute fractions and stuff like that here. Just a quick reminder, since we are talking through this one, when I distribute the negative 1/6 to the negative 5. Remember, you multiply the tops of fractions and the bottoms. If you have to think about it that way, you can think about the 5 as over 1. And think about it as the 5 multiplying by the 1 on top of the 1/6 and the 6 multiplying by the 1 underneath the 5. So you should get out 5/6 when you multiply. And then what's our last step? Subtract the 3. So often what you will see me do, and like I said, since this is review of Algebra 2, there are going to be things where I don't show every step anymore. So when I say subtract 3 from both sides, you might see me say subtract 3 here, but I'm not writing a minus 3 over there. Any guesses as to why? What do I need in order to subtract the 3 from the 5/6? Common denominator. So while I'm doing this, to save myself some time, I'm going to think about what is 3 in terms of 6. 18/6. So you'll see me write the minus 18/6 over here rather than the minus 3. That way I can quickly combine like terms and end up with negative 13/6. Yes, it has fractions. No, we frequently don't like fractions. They just have to become our friend this year. It's going to happen. Trigonometry uses a lot of fractions, so we're going to get there. If you don't like them yet, we'll get there. Okay? Any questions on that one? Places you feel like you didn't know what I was doing? I always kind of pause at this point and just say, we're going to get comfortable together. You're going to get comfortable asking the question that no one else wants to raise their hand and ask at 7:45 sometimes in the morning. Sometimes I'm going to do something that is wrong. Understand that. I make a lot of mistakes, not because I'm stupid, but because I work fast and I'm talking while I'm writing. So I'll say something and write something completely different, and someone's going to say, why is there a 2 there? Please say that. The last thing I want is to get the whole way through the question and be like, oh, shoot, I wrote the wrong number at the beginning. I had a college professor that did that in calculus, and he would start over here and make a mistake on the second line. And we'd all be trying to tell him, and he would just ignore us. It was great. So don't do that to me. That's my moral of the story for today. Moving on to question 4. We all remember the parallel to. Parallel to means that lines have the same what? Slope. Good. Now, in order to say that they have the same slope, we have to know what the slope of that line is. In order to find out what the slope of that line is, what must we do? All right, so take a minute on your own paper. Take that and solve for y. Again, if you're not comfortable going anywhere from there, pause. If you are, you may continue. All right, so I've got my line solved for y. What part about this do I care about? Only the slope. Please don't do anything with that 7/4. That does not matter. In fact, sometimes when I'm solving for y on these questions, I'll just stop when dividing when I have the slope because it doesn't matter. I don't need that. From here, I now have the slope. Parallel to means I'm going to use the same slope. Since I like to do side notes here, what does perpendicular mean? Opposite reciprocal. Equals opposite reciprocal slope. So you flip your fraction upside down and you change the sign. Okay? Now I'm going to use the same slope, so I'm going to use 3/4, and I have a point. What must I do with my slope and my point? Point slope form. Now, we just did that on the last problem. So here's my hope. You can plug your stuff into point slope form and solve for y. So take a minute on your paper and set that up. When you are finished with that one, go ahead and check your answer against mine. A couple places that it's easy to go wrong is in the distribution of your 3/4. I didn't write it up here, but when I'm distributing the 3/4 to the 6th, or to the 6th, in my mind, that's becoming 18/4, which then reduces to that 9/2. Then when I subtract 1, you see the same thing I did on that last one. Subtract 1 on the left, but subtract 2/2, which is my form of 1 on the right. Negative 9/2 minus 2/2. Remember when you are adding and subtracting fractions that you are subtracting or adding the numerators, but you're leaving the denominator as the common denominator. So it stays as over 2. Okay. Familiar to us? Somewhat? All right, one more linear question for us on the back. Number 5. When we look at that one, first we are told undefined slope. Secondly, with the same x-intercept as the given line. There's some key words here that I need to work through. One is undefined slope. We kind of talked about this on the previous page, but what kind of lines have undefined slope? X equals vertical lines. All right, then secondly, with the same x-intercept of this line. This is pulling a lot of things together in one question, especially for the first day. How do you find x-intercepts? Plug in 0 for y. That is the easiest way. Some of you might say solve for y, which gives you your slope and your y-intercept. You could graph it and see where it crosses, but that's the long way around. Now, I don't deny that the long way around will still give you the x-intercept. And if you are on a test or a quiz and it's I need to graph this and find the x-intercept, by all means, do something. Please, we are problem solvers here. We are not going to just say it has to be one way and only one way. Every year we go through a question where someone tells me a different way to do it, and I'm like, you know what? I never thought about it that way. And I love to hear that. But just know there's always different ways to find those x-intercepts. Was anyone ever taught to solve for x? Like a y equals mx plus b, but solving for x? You can do that too. The number at the end will be your x-intercept rather than your y. Odd, but it does work. The easiest way, however, is what we did say, plugging in 0 for your y. If I plug in 0 for my y, what does that do to my entire 2y term? Gets rid of it. I've got 3x is equal to negative 6. Therefore, when I divide, I get x is equal to negative 2. And this one is somewhat anticlimactic because what is this? It's also the equation of a vertical line. It's my x-intercept, negative 2. If I was looking for the x-intercept of that line, I would write it as negative 2, 0. But I was asked to write the equation of a line with undefined slope. That's a vertical line. So is that x equals a number the same as my vertical line? Yeah. That x equals represents two different things in this case, and I can stop right there. Okay?
Wait, how did you answer the negative 2 comma 0?
No, if I asked you for the x-intercept, that would be the point.
Okay.
Since this is asking me for a line with undefined slope, I'm going to leave it as x equals negative 2. Good question. Other review items here, distance and midpoint formula, they're not going to feature like super heavily, but I think all of us who have done SAT and ACT prep stuff knows that comes up anywhere and everywhere. So it's always good to go over. So your formulas for that, and I'll let you work on those two on your own. Your distance formula is x2 minus x1 squared plus y2 minus y1 all squared. Your midpoint formula, now your midpoint is a point, right? So it's like an x comma y. Your midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Kind of ran out of room there. So take a minute and try 7 and 8 on your own paper. One thing that I will say for sure is in 7, distances, I don't really want decimals for those. I always prefer the simplified square root. Now, that's if you can simplify. Can't always, and that's fine. Number 1, if you can take a perfect square number out of 109, you should. I really should edit this example to show that, but this one does not have anything to take out of it. If you're not remembering that, remember that's like factor tree the number and see what numbers go into that. If any sets of 2s or sets of 3s go into it, or like a perfect square like 4 or 9, people do that different ways. Some people are not factor tree people, whichever way you handle that. We'll see that on the homework, I believe. Secondly, on number 8, I will accept 2 different answers for that question, 2 3.5 or 2 7/2. I have some rules about fractions and decimals and square roots, actually. If you ever, like I know you have your calculators for your homework. If you type something into your calculator and it's a nice little run-on decimal that you're going to have to round, I don't really want that answer unless I've specifically told you to round. There are places that I will. Like 3.5, I'm totally fine with. That's not rounded off. That's just what it is. 7/2 divides evenly, 3.5, done. If for some reason it's like a third, where it's going to be like 0.33333 repeating, I don't really know why they teach you the little line over the 3 thing. Like, no one wants that. We all want the fraction. That's what we want. I want the square root of 109, not the decimal of whatever that is, because that's useless to me. So just understand, like, as we get into this, and then especially for calculus, we really want to kick some of those old habits to the curb. I really want to keep fractions when at all possible and square roots. But like I said, with 8, I mean, if I was to graph 8, I would switch 7/2 to 3.5. So, like, that's totally fine. It makes sense. If you ever have a question on a quiz or a test as to, like, how to leave an answer, ask. I'm happy to answer that question, or I'll specifically say it in the directions typically. But for homework, I'm not taking points off if you don't leave your answer the way I expected it to. Homework's completion. Now, completion, but like, I've got a good meter for just complete crap, okay? So just like going on the record for like looking at that, if it looks more like your English homework than mine, I'm just going to do a big circle and put the word no in the middle, and you're losing credit for it, okay? So I'm not going to do that. Actually, here's a good point to stop. Let's finish up with systems. There's only 2 examples here for systems, but I do want to talk about a couple different methods for this. When we talk systems, what methods do you remember for solving? Substitution. What else? Elimination and graphing. Graphing is going to be the one we don't really use that much. We will a little bit. Graphing will come up occasionally in odd places, because it doesn't just work on linear systems. It works on basically anything you can solve for y. You can graph it, see where they intersect. It's a great way to solve. We're not going to hit graphing today, just because graphing lines seems to be a little too far back for me. But we are going to talk about systems by substitution and elimination. And if you don't remember them, we are going to talk about systems by matrices. Okay, anyone remember doing those? Kind of, vaguely. It's the 3x3, type it in your calculator. Yep. So we're going to do that. So if you have a calculator, we're going to hit that after we do 9 and 10. If you don't, you can follow along with us up here. And remember that I will have it recorded so that you can go back and try it yourself. Now, these are super easy systems here. I do want you to recognize when's a good time to use substitution and when's a good time to use elimination. If we're being honest, I veer towards like elimination 90% of the time. And hopefully you guys do too, because elimination is that one where we like multiply everything by one number to make them cancel out, right? Yeah. Substitution, I only use, someone tell me when you use substitution.
It's like y equals.
If it's already y equals something, or you have a variable like in 9. 9 could be a good substitution one, although I won't use it for that, where you have the variable with no number. No coefficient, right? Anytime I could solve for an x or a y easily, that's where I could use substitution. But if it's already nicely lined up like number 9, I'm going to use elimination every time. Now, so that means 10 is where I use substitution. So remember, substitution is where, since y is equal to this, anywhere in the other equation I see y, I can take out y and in its place put what it's equal to. So that's going to look like 3x minus, rather than writing y, I'm going to put what's in place of y, 6x. And I'm going to solve for x. Subtracting gives me negative 3x equals 6. Therefore, x is equal to negative 2. Am I done there? No. In systems, you must have all variables solved for when you are done. Okay? This means I'm going to go back to one of my equations and I'm going to plug in my x to find my y. Theoretically, if you're the perfectionist like I am, you might check both because that's what tells you you're right. But the best place to do it is where y is already solved for, which is right here. So if I say y is equal to 6x, I can just go ahead and plug in 2 in place of x and get that my y is equal to what? Negative 12. Typically, we write our answers in ordered pairs. Sometimes this doesn't make a whole lot of sense with systems of 3. So I'm also okay with you saying my answer is x equals negative 2, y equals this. That's totally fine. Okay? Any questions on substitution? All right, elimination works so that you can cancel out one of your variables. Which one in question 9 is the best one to cancel out?
Y.
The y. Now, you can go ahead and say you're going to multiply by something here, or because the y's are just the same sign, what can you do? Just subtract. Now, if I subtract, notice I wrote my subtraction sign 3 places. Why do you think that is? Because you're subtracting everything, and if you forget that all 3 get subtracted, it's a quick way to be wrong. A lot of people will subtract just the y's and mess up either the 7 and 5 or the x's. So if I'm subtracting x minus 2x, I get negative x. Y minus y cancels. 7 minus 5 gives me 2. Therefore, x is negative 2. I was very creative with my answers on these two. Look at that. Now, this one, you have options as to where you would like to plug in your x. Either one will work, whichever one you feel like is easier. I kind of feel like the first one is easier. So in place of the x, I will put negative 2 and solve for my y, giving me y equals 9. Is this vaguely familiar to us? Yeah? So in a system of 3, we don't put the variables in at all. We just care about the numbers. This is what we would call a 3 by 4 matrix. Okay? 3 because it's how many rows? 3. 4 because it would be 4 columns. 1 column for the x's, 1 column for the y's, 1 column for the z's, and 1 column for the answers. We put that all in one matrix. Okay? We are going to use the reduced row command to help us do that. If you didn't remember what that was, that's what we use. So, for the 84s, I'll talk to one first, and then I'll talk to the inspires. For the 84s, I always do find the reduced row command first. I'm going to have to look off of someone's paper here in a minute because I'm not going to have those numbers. That's okay. All right, so first for the 84s, actually you put in the matrix first. On the 84, if you hit second and where it says matrix in blue, I really need to make this a little bit bigger here. I can't see it. Excellent. There we go. All right, second and matrix. All right, so for the 84, this first thing where it says names, this is the place that you go when you're about to do something with it. When we want to reduce it, if you want to multiply matrices, if you want to do something with it, this is where you go. When you want to put in a matrix, you go over to edit. So if you go over to edit, it doesn't matter which one you put this one in. I'm really not sure why they have so many options for so many matrices. If we're all being honest, we just use the first one every time. So I make matrix a 3 by 4. And it gives me 3 rows and 4 columns, which is actually kind of nice because you can actually check that it lines up with what you're trying to do if you switch the numbers. You just went in the wrong order. I'm going to literally take out the numbers from the x's, the y's, and the z's and just type them in. So I believe I said it was 1x plus 2y plus 3z equals 4. And then I went to 5x plus 6y plus 7z equals 8. And then I think 1 minus 2, oops, I'm going to have to use the negative, Remember to use the negative button for the -2 if you're on the 84. And then what did I say? 1z, and it was equal to 3. Okay. All right. So that's how you type that in on the 84. I'll come back. Inspire, you kind of do it all at once. So, yeah. At this point, it probably doesn't make a whole lot of sense, but I'm going to do second quit. Mainly because if you go directly into the math menu and choose something and this is not blank and you already have something there, it's going to mess with what you're trying to do. So either make sure your screen is clear before you go make the matrix or whatever. Do it after it. Now what we're going to do is go back into the matrix menu. This time I actually want to do math with it. And we are going to use the reduced row. Reduced row, if I keep going down here, is RREF, the double R. We want to use that one. Okay? So I'm going to hit enter. That's going to drop in the command. And then I have to tell it what matrix I'm reducing. Which matrix did I put that in? I put that in matrix A. So I'm going to go back into my matrix menu. I know. And go to A. Okay? It's under the names. So that's what you use to drop A in there. So when I go back into the matrix menu, that's when I use the names. A, B, C, D, whichever one I'm trying to do. If you hit enter, it'll work it out to a lovely matrix, whatever the answers are. Yeah, to me, with the 84s, you're like in and out of the menu a lot, and it kind of bothers me. But you know what? I'm not an 84 person. I'm the only person in the department that's not, so, it's fine. I will tell you this one is going to work out to fraction answers. I can tell because of the repeated decimals. You can use, real quick, this is a good calculator skill for you as well. Under the math menu, you can use these commands to change. All right, so if you would like to, I'll go back and show this one more time. If I had this and it's all the nasty decimals, and I want it to be fractions instead, go under the math menu. This little arrow fraction means turn whatever I had into a fraction. So if I hit that, it's going to turn my entire answers into fractions. Now, real quick translation. Remember, what variable was in the first column for us? What variable was in this column? X. So this one right here means X is equal to what? -1/6. This one in the second column means what? Y is equal to -2/3. And this one in the third column means Z is equal to 11/6. Okay, now, I promised I would talk to both because I see a mix and my Inspire people are waiting for me. Okay, if you are an Inspire, everything that is good on the Inspire is under the little button next to the number 9. Okay? The little button next to the number 9, I don't know what it's actually called, but I call it the templates menu because it's like what comes up with all the little boxes and stuff. So if you press the button next to the number 9 on the Inspire, it comes up with a whole menu of stuff. If my Inspire actually worked, it'd be great. That menu includes matrices. Okay? So, if you go into that button, the matrices that you want are the ones that are square brackets. It's basically right in the middle. Square brackets, it looks like a little set of 9 boxes. Yeah? If you go in there, it will ask you number of rows and number of columns. You will do 3 rows and 4 columns. And it will drop a little empty matrix box in there for you. You will type in your numbers. And then for those, I use the arrows to go back in front of the matrix. And then I use the menu to get the RREF. I feel like I have to show this. It's going to crash my computer anyway, but again for those. These over here in the middle, these are specific types of matrices. So if you specifically need a 2x2, use that one. If you specifically need a 1x2 or a 2x1, you can use those. This one right in the middle is like for any matrix size you want. So if you're not sure, just use that one. You can tell it to do 3 rows, or columns. It will drop in a blank matrix for you. And you'll do the same thing that they did on the 84 in typing in just your numbers. So we said it was 1x. Only on this one, don't hit enter. Use the arrows. If you hit enter, I think it like acts like you're doing something with it and then freaks out and you have to start over again. So 1, 2, what did I say? 3, 4. I made these numbers easy for myself to remember. So I've got that. -2, 3. No, that was a 1 and a 3. All right. Once you have your matrix in here, I use my arrows to go back outside the matrix because what we need is that reduced row command. Now, the upside to me of the Inspire is that if you know what the command is, you can type it using the letters and it'll use it. So if you don't want to find it, you don't have to. Like I know from the 84 that we just did that it's the RREF command. So if I do the letters RREF, I can just type that in. If you need to find it ever, this to me is what's easier on the Inspire is the menus. I mean, if you're doing matrix, go down to the matrix. And then you have this reduced row echelon form. That will drop the RREF in front of it as well. Or you can type it. Either way. Same thing as the 84 when you hit enter. Mine is set up to do fractions automatically. If yours is not, you can do the same thing that we just did on the last one